Today we're going to see what's inside a drone.
We're not recording this video alone, Wanzam.
Welcome. Look, this guy here has been working with drones practically since drones were invented. When did you first fly a drone?
The first time was in 2008, but it wasn't really a drone yet, right?
But had you already worked with that before?
Yes, I was a model maker. I had been a model maker since 1984.
Did you assemble the airplanes?
Model airplane builders have always built them, right? Brazilian builders are the most creative worldwide, maybe from necessity or curiosity. So he's an assembler. He's really a maker.
Check out what Wanzam brought, a model airplane drone.
This is a tricopter, built before drones were common, so it wasn't designed for filming or photos. More like a model airplane. It was just a toy. We had helicopters and airplanes, but not a device like a tricopter, right? A multi-rotor that could just hover there. So that was actually the beginning of drones. So it's called a tricopter. It's part of the multi-rotor class, and today we know it as a drone.
This one didn't carry a camera.
No, not yet, because up until then, we used it just for fun. It's all made of wood back there.
There's a Mafagafo's nest in here.
In this engineering, you have to do reverse engineering to understand how it worked. That's right.
Did you buy it ready-made like this?
No, nothing here is ready-made. The engines came from model airplanes, and we actually cut small pieces of wood ourselves. This one is a laser cut. Back then, I was just starting with the first laser cuts, but we used to cut with water, when it wasn't done by hand, right? The first ones were done by hand, with a little saw, right? We had to build the body to support the electronics.
There was no automatic control?
This one is already somewhat modern, but the earliest versions used a gyroscope. There were 3 gyroscopes, one for each arm's motors, plus another for the small rear servo arm. When it took off, it would raise its little arms and start flying. This motor and that one both spin inward to break torque. Then a third adds more torque here. So, this motor worked at a slight angle like this to break its own torque. This here, to turn, this motor would tilt this way. It would turn and tilt its back end in different directions.
It's like a helicopter tail, but it still flies.
It flies. As incredible as it seems, it flies. It just does presentations at events, that kind of thing, but it flies.
The first drone I saw was this one, which is our victim today.
Poor thing.
It's the Phantom One, a drone that changed history, right? I believe it was the first ready-made drone you could buy.
Exactly. That's the plug-and-play one. The first drone you could just fly without building anything.
This one must have flown a lot.
Yeah, all of them. All of them are flying. They're a bit worn out, but still flying, right?
This drone doesn't have its own camera. You needed to attach a GoPro. You can see it clearly here, right?
This one is already equipped with a battery and everything.
Bring a GoPro underneath. When it flew, you couldn't see its recording. The drone returned and you watched it later.
It was a hassle, right? You'd take the shot, remove the card, check it on your laptop, then realize, oh, needs more to the right. In other words, there was no preview of what you were doing.
He also has much less control over the flight, right? Like the drone we have at Manuel do Mundo. When you release the controller, it stays in the air as if there's a floor under it. This one doesn't do that, right?
Drones were a new concept, and the idea of remote piloting was just beginning to develop. You needed sensors to pilot this drone, right? So things like barometers, accelerometers, and magnetometers started to appear, and then when GPS came along, when GPS stabilized the drone, this global positioning system, it connects to 9 satellites, the minimum needed for a drone to stay in flight. So it was flying with just enough to survive. If it lost 2 or 3 satellites because of rain on the horizon or a cloudier sky, it would go crazy, fly away, and never come back. So it happened. Many situations like that, right? Now, if you take one of these drones here, from these new generations, it's a drone that works with almost 32 GPS satellites. And it only needs 12 to fly, which is excellent, right? So, I mean...
Can it lose satellites freely? This is a first-person view competition drone. The one that does flips, that goes under the bench?
Yeah, it does flips. I call them flips, but the guys don't like that term.
Oh, you can't say flips? Sorry, it does loops and more.
The propeller is already below.
Yeah, this one has a propeller guard exactly so you can fly it indoors, right? So you can fly close to people. If it hits something, the propellers stop, but it keeps flying. It just gets a bump and keeps going, right? And if it bumps into someone, it doesn't do anything.
Very different from this other one here, which didn't have any of that. This one is still flying, isn't it?
Yeah, it's flying.
Shall we test this little guy? Let's make it fly to fire.
Let's go.
Get over this little fear here.
Just so you know how it was.
Shall we fly this thing?
Let's go then. It's a bit rusty, isn't it?
Has it been a while since you started it?
Around 8 years.
8 years? Ah, he started up slowly.
There you go. Look, it's flying just right.
Ah, it's looking nice. Look.
Smooth as butter. Steady, see?
No, to me, he was more rebellious.
He's more rebellious than kids today, so you have to chase after him, right?
No, because he keeps floating, right? He doesn't stay still, right?
No, not this one yet.
If he were recording, we wouldn't know what he's capturing, right? You have to rely on sight.
Yeah, the higher it is, the more stable. Because it starts picking up the 8th satellite, you know? The 9th satellite, you know? Its processing was pretty bad, right? This is the first plug-and-play drone, right? And in these conditions, with the sky like this, it's totally reliable.
But it's also really heavy.
It's not that it's heavy. It's actually lighter than some drones today. But its principle, the way the propeller works, the size of the propeller, makes it kind of dead, right? With the motors running slowly, it acts like a punching doll. Modern drones this size have smaller propellers, so it spins faster and the motor stays steadier in the air, making it more stable. Want to try flying it?
Let's go, let's go, let's go, let's go, let's go. Yeah, it's slower, right?
Yeah, it's like a rubber band effect. It's stopped. The red light is blinking, meaning the battery pushed and is now dead.
Ah, it's already struggling, but does that light actually mean the battery's low?
Yeah, it's maxed out. It can't keep its power efficient to the end anymore, right?
Let's land Jumbos.
So the touchdown control, you'll have to do it because it doesn't have touchdown control.
Oh, it doesn't have a sensor.
When it touches down, keep the throttle fully down. Yeah, man.
Ah, it's actually pretty damn good. I wanted to do that experiment we were talking about, which is this. I've always been really afraid of putting my hand in and cutting it on the propeller.
This drone had many issues due to its fixed propeller.
It hurts more, right? We wanted to test putting an apple on the propeller to see the damage. Let's do it.
Just to make sure, a new battery, right?
The idea is I'll be holding the apple, you come in with the drone and just give it a little whack.
An idea is just an idea, right?
Yeah.
But all right, let's go. Let's test it.
But what could go wrong? Of course I'm scared. Just letting you know that this is being done by extremely professional people. In Wanzam's case, not me. And you shouldn't try this at home because I know the risk I'm taking, all right? Ah, it's fine. Go ahead.
Hold on a second, wait. There you go.
Woohoo!
What's up?
Man, it hit my finger here, but it didn't do anything. Whoa! Holy mother, that's a mess, man. After it hits, it doesn't even respond for itself anymore, right?
They don't make this drone anymore, right? Because of a lot of problems that happened in the past, they stopped making them. The drones today used to cut a lot of people. The foldable propeller folds in on contact, preventing injury to a person's hand. We had no idea. We used to fly without even realizing it, right?
Let's take this little guy apart since it hit my finger and deserves it.
Hey, crazy. Were you saying you're going to take the whole drone apart? No, right?
Of course, the drone is going to be completely taken apart, right?
Will you be able to put it back together again?
No, then, you already saw, you know what you're getting yourself into. We take things apart really well here, but putting them back together depends a bit on luck. This was the camera, and it's already taken a few hits too.
This camera was right underneath the drone, so the arms would hit, the legs would hit, and it was always back there.
There's a little leg here with a tiny chip at the tip.
That little chip there, it's a tiny magnet that gives it magnetic orientation. In other words, it gives it a north, right? So it stays stabilized on a north.
Is it the electronic compass?
You could say it's a compass, right? It's placed away from the drone because it suffers a lot of magnetic interference.
The small wire is an antenna.
This is one of the antenna's two small tails. This here is the control antenna, right? Forward, backward, to one side and to the other.
It no longer has a leg.
Taking off the propeller will make it easier for you.
Good, is it working? I don't think so, is it? You'll want to put it back together later, right?
I intend to, right?
Oh man, I'm about to mess this up again. It's clear this drone wasn't designed to be assembled in one piece.
It was taped up, right? I use tape on many of my drones.
Each motor has 4 screws just to hold the motor base. Shall we see?
Ta-da-ta-da-ta-da-ta-da.
There's a lot of duct tape here. Now we can do this scene again like this, look. Man, there's a lot more stuff than I thought, you know?
Yeah, there is.
There's a lot more stuff than I thought.
I think that's pretty basic, but to someone unfamiliar, it might seem complex.
I'm the person who doesn't know much, so I think there's a lot in here. Is this the global positioning system antenna?
This isn't ordinary duct tape. It has a copper sheet layer.
So an electromagnetic shielding is used here to prevent interference?
Exactly. Now you'll see the size of the GPS antenna. Today's antenna is just 10% of that size, but nearly 5 times more effective.
Let's first understand the purpose of each item here. These are the motor controllers.
It's an electronic accelerator.
Each motor needs one here.
Each motor spins in the opposite direction, with 2 motors opposing the other 2 to generate torque. This motor spins this way and brings this frame here. This one spins this way and brings this frame here, and so on.
Just like a helicopter, it needs that little tail rotor in the back, because if it doesn't have it, it keeps spinning. The body of the helicopter spins along with it, right? Here in the middle, this small black board is the little guy's brain.
Yeah, that's the controller. It flies the drone, keeps it stable, hovers, and brings it home. All that Chinese stuff is inside.
I already knew he didn't want to mess it up too much because he brought one of these separately just to take apart. Look at that.
Isn't it because this one is flying perfectly?
Yeah, that's the trick.
And that one isn't so reliable anymore, right?
You've already brought a broken one here. Let's open this one then.
Did you see that there's a receiver here that gets the information from the radio here? So, all the commands from the radio are sent to this receiver, which in turn sends them to the controller.
And this green board, its function is...
It's to put everything together and power them up, right?
It's more like a support for the other things than an actual electronic board itself, right? Let's check out the little guy's brain.
All the sensors, including the accelerometer and magnetometer, are inside.
The barometer is here too.
Then you put all that together with a GPS signal that comes through that antenna over there, right? That makes the drone work properly. That foam is there to let the controller and sensors float, making them less sensitive to vibrations, right?
Is everything inside a little zinc box here?
Now, inside this little box, even I don't know what's in there yet, right? In terms of physical components.
Are you curious to see?
Want to open it? I'm curious too.
Me too, I'm curious.
I've never taken it apart that far, you know?
Man, this is practically the drone's black box.
It's very rigid. I thought it was that tough.
It doesn't break at all. Wow, man.
No way, man. No way.
Now it worked. It's a tiny plate right here, see? We tried to break it, thinking it was just a thin wall. Actually, it was a solid block of some kind of metal here, like that formed metal. It's when you make that powder and then press it. I don't know the name of this type of metal.
I'm more curious than you.
Are we going to mix uranium with plutonium or something like that? I guess that most of the stuff is here. There's also a chip with...
It's a processor chip, right? A little processor right in the center there, right?
There's a big blob of resin here.
It was common for them to put that there, so people wouldn't find out what's inside, right?
Let's organize this so people can understand how it works. Now it's not working.
It's really dead.
Now there's no saving it. It's done for. Look, it has the LED underneath. For those who thought there was nothing inside, this is pretty good. First thing, the battery powers its brain here, right? Which will distribute power to the other components. You turn on the drone and the receiver will get that information. That will go here to the brain. That's it. Here it will check if there's GPS, if it's tilted or not, if it's going up or down. Everything is being controlled in here. So this receives and manages the GPS signal, right? Here we have an electronic compass. Through these little cables, we have the power coming to the motors that I cut.
Yes.
Here's the information on whether to speed up or slow down.
Positive.
And here, the motor we're using is just one, to keep it simpler.
The final propeller, which goes on top, is what creates the mechanical effect, right? Simple. Wonderful, right? Just like that, simple.
Not easy, right? There's absolutely nothing simple about it.
It's primitive, but definitely not simple.
Nowadays, everything comes on a single little board, probably.
It boils down to 10 times more powerful, with 10 times fewer visible components, right? For example, a tiny board has all that, but 10 times stronger.
Amazing, Wanzam. Thank you for the opportunity, amazing. To check out Wanzam's channel, use the link in the description or the card. It's really cool.
You can go up, you can go. Go ahead. That's it. That's right. Good boy.
Man, that's delicious. And he flies inside the house just fine.
You can come in, no worries.
Going outside, now I'm gonna jump over the wall too. I got really rebellious, man. It even gave me butterflies in my stomach here, but his control is really good.
Very, very.
And I hit the wall and it fell on the floor. Oh, I fell. Look at the little guy over there. Really cool.
It's cool to see you there, right?
No, that's just how you feel. Whoa, are you going to make a move?
Ever feel like playing video games? Pretty crazy, right?
Wow. Hey.
But usually we grab it from above here, right?
Oh, okay. Oh.
To turn it off, you usually grab up here. I turned it off, right?